Well, this one's got a lot of words. Suppose you are conducting market research about a new product and you hold a focus group with 15 people. You ask each person if they like the product or not. Let L be the random variable of the number of people who like the product. Assuming everyone has the same probability of liking it and they all choose independently, then L is a binomial random variable. Oh yeah, I guess that makes sense. The 15 people would be the trials, like asking them would be the trials. And there's only two options, they either like it or they don't like it. And we've counted how many people like it, so success is liking it. And the probability of the success is the same every time, and they're all independent, so that makes it a binomial random variable. Cool, I'll write that down. L is distributed according to a binomial random variable with 15 trials, and I don't know what the probability of success is yet. You would like to know what to expect for the results of your focus group, so you decide to choose some numbers for the probability of success and calculate some features of the random variable L in each case. Okay, so we're going to pick different things. So I'm just going to call it P. Calculate the expected value and the standard deviation of L for each of these probabilities of success. 0.3, 0.5, 0.7. Okay. P equals 0.3. Okay, well, the expected value of L for a binomial random variable, normally this is called n, and the expected value would be n times p. So it'll be 15 times 0.3, because that's what the p is, which is 4.5. Okay, cool. Now it doesn't matter that that's not a whole number because it's just an average. So it's saying on average it's about 4.5, so between 4 and 5. Okay, the standard deviation of L, sigma L, has a formula 2. It's the square root of n times p times 1 minus p. So n is 15 times p is 3. 1 minus p would be the rest of the probability, so that would be 0.7. And so we've already got the 15 times 0.3, so I'll times that by 0.7, and then I'll do the square root of the answer, so that'll be 1.775. Okay. Right, well, that doesn't mean anything much yet, so I'm just going to try for the second one. P is 0.5. The expected value of L is the number of trials times probability of success, and I know that that's half of 15, so 7.5. And the standard deviation will be the square root of 15 times 0.5 times 0.5. All right, so I'll definitely need a calculator for that. The square root of 15 times 0.5 times 0.5, which I got in brackets there so that the square root applies to all of it, 1.936. Okay, so the standard deviation is bigger for this bigger probability, which is interesting. So that means the results are more variable. So on average, they might be 7.5, but they can be further away from that more often than these can be further away from the 4.5. All right. What about this third one, 0.7? The expected value of L would be 15 times 0.7. 15 times 0.7, which is 10.5. Okay, and the standard deviation of L is 15 times 0.7 times the other probability, which is 0.3. I've already calculated that. It's exactly the same as this one. These two are just switched around, and that doesn't make a difference to multiplication. So that'll be 1.775 again. So that's really interesting, actually, because even if I had 0.2 and 0.8, they'd have the same standard deviation too. So it looks like the standard deviation goes up until 0.5 and then goes down again. So the most variable thing happens when the probability is exactly 0.5. So I guess if I didn't really know what the probability was, my best guess, my worst case scenario for how variable it would be picking 0.5. Okay, that's pretty interesting, actually.